Hello everyone, I hope this video finds you in warm weather or warmer houses if you're watching this to study. This is really going to be a quick video. I'm going to go through the review a little bit. I'm going to skip the topics that the test is covering to focus mainly on topics I discussed in class. However, you can find all of this on the daily agenda for 1026 to 1027. Your homework will be the review guide. I am going to go a little review with valence electrons and octet rule. However, do not worry about that being on the test. I took those out because a lot of it was review. As you recall, valence electrons from physical science, they're electrons in the outermost energy level, and they're the ones that move and or are shared in chemical bond. These are the ones that help us determine what kind of ion is formed, and they're always on that outside. They're probably the most important electrons. Nothing against the other ones, but we pay more attention to them. Valence electrons, you can determine them by period, so it's really easy where if I'm in the first group here, then I only have one valence electron, whereas if I'm in the 8th group, I will have 8 valence electrons, with the exception being helium. And then it increases, so it makes it easy. Valence electrons are the outermost electrons. So while boron has 5 total electrons, there's only 3, because those 3 are on that outer shell, where the other 2 are in the inside. And as you recall, noble gas configuration can actually tell you what the number of valence electrons are. Again, don't worry about it. This is just something that you need to know, where you can do it with the Bohr model or electron configuration. The octet rule states that in forming compounds, atoms tend to achieve the electron configuration of a noble gas. So if I want to have 8 in my final ring, I pretty much get 8 valence electrons, just like a noble gas, and to do this, they'll either lose, gain, or share. An example is sodium has 11. Typically, it would only have 1 valence electron, but it wants to go to that octet rule because it means that it's stable. And to do that, it's a little bit easier to lose 1 electron than gain 7, so it'll lose an electron and become a sodium positive 1, but that gives it its 8 valence electrons, and that's what makes it stable. This is an example that we did in class, so please take the time to actually do this if you need the practice. However, here are the answers. Okay, you can kind of tell the bottom one is 0 and the bottom charge is +2. This is all on the daily agenda for your test, and it's on the review guide. But this is just a quick reminder. So you do need to understand electron configurations. I need you to know the shorthand way on how to represent where electrons are and be able to understand the information that's given to you. With that, I want you to know box and arrow. I want you to know the full shorthand configuration and the noble gas configuration. Make sure you know that 3D becomes between 4s and 4p. Make sure that you have this on your periodic table, as you can use that on your test along with your review guide. Here's a better sense, like just a visual, if you need to see something that's like written out of like where is each electron and their orbital and energy level. The reason 3D comes after 4s is what we call the Aufbau principle, where energy fills from the lowest to the highest energy level. That's the reason why, and here is the order. Here's another visual for you, and then you can do the shorthand electron configuration for an ion, but when you do that, make sure you're paying attention to the electrons. We can get something that looks similar across the board for all of these because of that, but it's just important to know that when you're doing electron configuration, you're always going to do the number of electrons, even if it's an ion. Other than that, that's all I have for you today. If you have any questions, please let me know, but work on your review guide, and have a good day. Bye.